welcome to the Online Learning Channel. I am Mrs. Perumal and today I will be doing maths for grade 5 learners. We will be focusing on whole numbers. This includes counting forwards and backwards. We'll be doing comparing and ordering of numbers, and we'll be doing place value of numbers. We'll also focus on mental test, which has to be done every day for 10 minutes based on bonds, addition and subtraction, and multiplication as well. Okay, now we're going to go on to my PowerPoint presentation that I have prepared for you. Right, our first part of it is going to be counting, ordering, comparing, and representing digits for place value of numbers. Now, when it comes to counting, we are going to count forwards and backwards. And I'll explain to you in detail what you've got to focus on, what you've got to practice every day. Ordering and comparing of numbers, you will be able to identify if a number is bigger than another number. We'll be able to do this by doing ascending and descending order, number patterns, as well as greater than or less than. And finally, place value, where you'll be representing digits for the place value of numbers. Here you will do Dean's blocks, you will do the reading of the abacus, expanded notation, writing numbers in words, words in numbers. You will understand all of that. So let's start with the lesson now. We're going to start immediately with counting. Counting is very important because you need to know how to count forwards and backwards. This aids in your number patterns as well. Now, counting, before introducing any lesson, mental mathematics must be done for 10 minutes. You'll focus on bonds and tables, right? For example, you will do your bonds this way here. These are number bonds, which has number facts in them. We'll be focusing on addition and subtraction, basically. And while we're doing this, we will work on inverse operation. So let's look at this here. This is a diagrammatic formation of bonds, right? Generally, in a classroom situation, you'll get it like how it's written on the right-hand side. Now, 10 is my whole number. These are two parts here that make up this whole number. So 7 plus 3 gives me 10, or 3 plus 7 gives me 10. So part plus part gives me whole, part plus part gives me whole. Or I could do it the other way around. Whole minus part gives me part, and whole minus part gives me part. So what that means is 10 is the whole number, minus 7, which is the part, gives me 3, which is the other part. Or whole number, which is 10, minus the part 3, will give me the part 7. So we're using inverse operations to get our answer. Now, let's look at this example. Here we've got 10, which is the whole number, 8 and 2 are parts. So part plus part gives me whole, 8 plus 2 gives me 10, or 2 plus 8 gives me 10. Or I could say whole minus part gives me part. So 10 minus 8 gives me 2, or 10 minus 2 gives me 8. Right? Now, this I will show you in a video clip now, which will make you understand it better.
In this video, you are going to learn how addition and subtraction are linked. Why is this relationship important? Because we can use it to help make maths easy. Here is a simple equation, 2 plus 3. When we add 2 and 3, we find the total is, you've got it, 5. In this example, 2 and 3 are called the parts, and the parts make up the whole, which is 5. We can represent this equation using a part-part-whole model. The parts go in these small boxes, and the whole goes in the larger box. This is another way to show that 2 and 3 make 5. The part plus the part equals the whole. That means that 3 plus 2 must also equal 5. So we know that part plus part equals the whole. We can also use this part-part-whole model to represent subtraction. If our whole is 5 and we take away the part 3, we are left with the other part, 2. 5 take away 3 equals 2. The whole take away one part equals the other part. Let's try the turnaround. Because we are doing subtraction, we must still begin with the whole, but this time we will subtract 2. We are left with the remaining part, 3. Let's have a look at another example, 4 plus 6. Our two parts are 4 and 6. Let's add our two parts to find our whole. 4 and 6 equals 10, whole is 10. Part plus part equals whole. 4 plus 6 equals 10. And 6 plus 4 equals 10. Whole take away part equals the other part. 10 take away 4 equals 6. And 10 take away 6 equals 4. So we know addition and subtraction are related, but why is this relationship important? Well, it can be really useful because we can use addition to help us solve subtraction problems. Let's take a look at this equation. 19 take away 17. 19 is the whole. 17 is the part that we must take away. The equation is asking us to work out what part will be left over. Work this out by subtracting 17 from 19, but there's an easier way. Let's use the relationship between addition and subtraction to turn this problem around. We know that the part plus the part equals the whole. That means 17 plus something equals 19. We know that 17 plus 2 equals 19. That means that 19 take away 17 must equal 2. Let's try one more. 11 take away 8. Because it's subtraction, 11 is the whole. 8 is one of the parts, and we are missing the other part. Let's think about this as an addition problem. 8 plus something equals 11. 8 plus 3 equals 11. That means 11 take away 8 equals 3. Using addition to solve subtraction is easy. EasyTeaching.net.
Okay, I hope that helped you a bit. Let's go back to the previous slide. Here again, what they explained to you there was whole, part, and part. Now, when we look at a more difficult one, for example, 19 minus 3, these 19 is your whole, 3 is your part. So whole minus part will give you another part which we're not sure of the answer. So what we're going to say is 3 plus what will give me 19, which is 16. So part plus part, 16 plus 3 gives me 19, or 3 plus 16 gives me 19. Or 19 minus 3 gives me 16, or 19 minus 16 gives me 3. So please use the model that I've shown you here and complete this activity of the more difficult ones. It will be easy. You will catch up. Now let's look at multiplication of whole numbers. Here we've got multiplication of 10. Multiplication of 10 is one of the easiest numbers because you're basically counting in tens. And you take any number times 10, you add a 0 next to that number and it gives you the answer. So if I tell you 200 times 10, I'll take the 200 and I add a 0 there and my answer is 2000. 100 times 10, add a 0 next to the 100, gives me 1000 and that's my answer. 6 times 10, add a 0 next to 6, my answer is 60. So it's simple as that. So just go over your tables of 10 times 10 or up to 10 times 10. And you will be able to do all the more difficult ones by just adding 0 next to the digit in front. Now, another important thing to do is your tables. Tables are very important, kids, especially when you are doing your multiplication and division in class. Now, lots of children get the sums wrong because they don't know how to do the table. They don't know the tables. They don't learn it. Nobody tests them on it. So you take the time and your parents to please go over this tables chart, learn your tables, and get your parents to test you every single day. Not on different tables, one a day is sufficient. So for example, if you want to learn 6 times table, you will write it down, learn it for ever long until you know it, and then you will recite it to your parents. Even if you rote learn it, it's perfect. So for example, we'll read this table vertically and horizontally. So I'll say, for example, 6 times table. 6 times 1. My answer will be on the first line below 6, which is 6. 6 times 2 on the second line below 6, which is 12. 6 times 3 on the third line below 6, which is 18. If I'm doing 9 times, same way. 9 times 1, first line under 9, which is 9. 9 times 2, second line under 9, which is 18. 9 times 3, third line under 9, which is 27. So my tables basically are going down. So if I'm doing 6 times table, 6 times 1, 6, 12, 18, 24. Again, our tables is counting in a specific number, your multiples of your number. So please don't forget to learn your tables, know them. You'll be more confident when you're completing work in class or when you're writing a test. And it saves you a lot more time, believe you me. It saves a lot of time when you know your tables. Now let's go to counting. Counting, right? We will be able to do it forwards and backwards. You must be able to count forwards and backwards. So write it out, practice it. Take certain numbers, for example. You're going to learn to count up to 10,000. But we will start with the easier number, 1,000. We'll have to count in 2s, 4s, 5s, 10s, 25s, 50s, or 100s. So take a page, write down them, counting in 10s. I gave you a chart at the bottom here to help you. But this is the hundreds chart. But let's go to the 2s, for example. So if we give you any number, you say that count in 2s from 100 to 110. So you'll say 100, 102, 104, 106, 108, 110. But if you count that backwards, it'll be a little bit more difficult. So rather write it out, and then when you write it out going forwards, you can start from the back, which will help you. So you'll have 110, 108, 106, 104, 102, and 100. So the same thing you'll do with 10s, 25s, 50s, counting those numbers up to 1,000. Practice that every day. Today, focus on 2s. Tomorrow, 4s. The next day, 25s or 50s. They're not difficult if you practice it. Use a number chart to help you, and then you write it on your own, and you will understand how to count. Then you can use this number chart to help you when you're counting in hundreds to up to 10,000. Now, you can from anywhere. For example, if I tell you count from 500 to 4,500, say 500. Okay, just say 500 to 1,000. 500, 600, 700, 800, 900, 1,000. If I tell you from 5,700 to 6,200, so you'll say 5,700, 5,800, 5,900, 6,000, 6,100, 6,200. Now we're counting backwards from 9,600 to 9,000, 9,600, 9,500, 9,400, 9,300, 9,200, 9,100, 9,000. So use this chart to help you. And if you're having any problems, go back to the chart, practice it again, and you'll eventually get it right. Now let's look at this. These are other ways of counting. Here we're counting in 3s, 4s, and 5s. For example, now the first one. Look at the number, whether it's going up or down. 27 to 30 is going up. 27 to 30. 30 minus 27 gives me 3. So the difference here is 3. Now we're going to move on. 27, 30. I have to add another 3, 33. Another 3, 36. Another 3, 39. Another 3, 42. Another 3, 45. And then 48. But if your counting is incorrect, remember, the sum is going to be wrong and you're going to lose marks. Here again, 16 to 32. Now remember 16, generally in 4s, not 3s or 5s, because you can divide 16 by 4. So let's start. 16, 20, another 4, 24, another 4, 28, and then you've got 32, and you continue. 100, not 3s. You can use 4s, but I've got 130. So it's generally here, you can see it's 5s. 100, 105, 110, 115, 120, 125, 130. So you've got to determine what we're counting in 3s, 4s, or 5s here. Now on this side as well, we've got 2, 4, 6, 8. We're counting in 2s, so you can complete that. 10, 12, you'll complete that. Here we're counting in 3s, 3, 6, 9, 12, and you can complete that. Let's go further down. 10, 20, 30, we're counting in 10s. 8, 16, 24, 32, you're counting in 8. So you must determine the difference between the second number and the first number for when you're counting. So 4 minus 2 gives me 2, so I'm adding 2 each time because the numbers are going up. Take the second number again. 6 minus 3 is 3. So I'm adding 3 each time I'm going up. Here as well. 18 minus 9 is 9, so I'm adding 9 each time. 22 minus 11 is 11, I'm adding 11 each time. So that's how you'll complete these activities. Now, let's look at another way of doing number patterns. Now here, number patterns can either go upwards or downwards, depending on the number. Here we can see 48, 49, we're adding 1 each time. 24 to 34, 34 minus 24 is 10. So here I'm adding 10 each time, and you can see the rest what you're adding each time when you're counting. But let's look at this. I want you to focus on this one here particularly. I've got 30, then I've got 27. What's happening here is the numbers are going down. So I'm going to minus each time. So 30 minus 27 is 3. So then I've got to minus another 3, which gives me 24. Minus another 3, 21, and so on. So always look at the number. Here's another one. 40 minus 38 is 2. So I'll minus 2 each time. 38 minus 2 is 36. 36 minus 2 is 34, and then you continue that. So always look at the number when doing number patterns. Is the number going up or is the number going down? If it's going down, find the constant difference and add it each time. If it's going down, subtract the number each time, the same number, and then you get the correct answer. So please complete these activities. It's going to help you. Let your parents check it and they'll be able to tell you whether you've done it correctly. Now we're moving on to place value. What is place value? When we look at a number, we need to know what's the value of each of those numbers before we read that number, or we won't be able to read a specific number. Now we're going back to grade 4 work. Here we are looking at the value of numbers up to 1,000. In this blocks here, I've got Dean's blocks. I don't know whether you've come across Dean's blocks before, but these are Dean's blocks. Now, this here is the flat block with 100 in each one. There's the flat block here, it's 100. 100 times 10 in each row gives me 1,000. So this here is equal to 1,000. Right? And then here I've got 2 flat blocks of 100. Here I've got each of these sticks is equal to 10. So it's 10, 20, 30, 40. And then you get single digits, but doesn't make up 10. And this gives me 7. So 1 times this 1,000 is 1,000. 2 times this 100 is 200. 4 times this 10 is 40. And 1 times this 7 is 7. So here I've got 1,247. So 1 times 1,000 is for that, it's 1,000. 2 times 100 is for that, it's 200. 4 times 10 is for this, which is 40, and 7 times 1 is for this, which is 7. So 1 times 1,000, my answer is 1,000. 2 times 100 is 200. 4 times 10 is 40, and 7 times 1 is 7. Eventually, I have to add up this to get the final number. But what I've done here is I've broken it up so I understand the value of each of my numbers. There, I've even broken it down on the top for you. So please go through this as a revision of grade 4 work. Now, when we go to grade 5 work, we are going to go up to 10,000. Now this here is a place value house, which makes it more fun when we are doing the sum. Now you are familiar with 206, how to read the numbers here, 100 tens and units, which gives me 206. We read it as one entity. As well as this is the thousands, it's also made of 100 tens and units, but we read it as one entity as well. So this is read as 73 and this is read as 206. Now on the top here, it's telling you thousands. So we'll say 73,206. So how are we going to break this down now to understand it? Now, 73,206. This is my 10,000 column. This is my thousands column. Hundreds, tens, and units. So 7 times 10,000 gives me 70,000. 3 times 1,000, 3,000. 2 times 100, 200. 0 times 10 is 0. Any number times 0 is 0. Always remember that. 6 times 1 is 6. So 70,000 plus 3,000 plus 200 plus 0 plus 6 gives me 73,206. And written in words, it will be 73,206. Right? So remember that when you are doing it. Always do it this way. Expand your number, understand what each value is, write it in the full numeral form, and then you must learn to write it in words. And always remember here, any number multiplied by 0 is always equal to 0. Right? So I hope you understood this place value house and how we read it. Now we're going to go to the abacus. When reading an abacus looks like these 2 diagrams here. Right? We will look at the digits. Starting from the left here is your units, your tens, your hundreds, your thousands, and your 10,000. It's the same as the value house, place value house. It's your units, your tens, your hundreds, your thousands, your 10,000s. This is the same way, but we're reading it in different diagram forms. Here as well, there's another abacus here, right? It starts with 4, 3, 6, 2, and 7. So let's look at the first abacus. Each circle here must be counted for each line. So the first one is 3, then it's 8, 2, 1, 5. When I write it together, it reads 3, 8, 2, 1, 5, as you can see at the bottom. When I expand that number, it gives me 30,000 plus 30,000 plus 8,000 plus 200 plus 10 plus 5. And in words, it's 38,215. Same with this one. Let's look at it. 4, 3, 6, 2, 7. When I break it down, it'll be 40,000 plus 3,000 plus 600 plus 20 plus 7. Written in words, 43,627. So it's similar to reading this or going to this, but in different forms. Let's go now. I hope you understood this here. Let's go to the activity of it. Now here I've given you the same thing. So if you read it, you've got 2, 3, 2, 1, 1. So that's 23,211. Now when you're doing this, don't just write the answer and leave it. Take a page, write down the number, expand the number. So here you'll say 2 times 10,000, 3 times 1,000, 2 times 100, 1 times 10, 1 times 1. So what does that entail? 20,000 plus 3,000 plus 200 plus 10 plus 1, which will give me 23,211. So this you'll do on a page, and you'll practice all these the same way. You'll write out the number, expand it, do your expanded notation, and write the number out in words. That will help you build your confidence when reading numbers. Now let's go to the Dean's blocks, which we spoke about earlier on. I told you this 3D one here is the thousands. This is your hundreds, your tens, and your units. This is what they represent when you're looking at Dean's blocks. Now they're representing whole numbers to you, and each of the pieces here represent a specific value. So the single big block is 1,000, the single flat block is 100, the single stick of 10 blocks is 10, and the single block is 1. So it's 1 digit. Now let's look at this example. This is a different example from that one. Here I've got 1 big block, 2 single flat blocks, 3 sticks of 10, and 1 block that, if you count each digit here, it gives you 7. If you count each of those numbers, it gives you 7. Right? So 1 times 1,000, there's it here, which is 1,000. 2 of this will give me 2 times 100. 3 sticks of 10, 3 times 10, and 7 single digits here, it will be 7 times 1. So my answer will be 1,237. So they have broken it down. We have 1 big block, 2 single flat blocks, 3 sticks, and 7 single blocks. So it's 3 sticks of 10. And 7 single blocks, which is 1,237. And there I wrote it out in words again. I broke it down, expanded notation, wrote it out in words, 1,237. So you know when you're counting, count how many blocks of this, that gives you how many thousands you have, how many blocks of the flat ones, how many hundreds you have, how many of the sticks of 10, how many of that you had, times it by 10, and how many single blocks times it by 1. Let's look at an activity now. There I've given you an activity. Let's look at the first one here. You've got 2 blocks of 1,000 here. 2 blocks of 100, 3 sticks of 10, and 1. So 2 times 1,000 is 2,000. 2 times 100 is 200. 10 plus 10 plus 10, or 3 times 10 is 30, and 1. So it's 2,231. So you'll write your answer. So you'll do all the activities for this and write your answer down. Here as well, the answers are here on the side, but you can do it on your own. Block the answer. You count for yourself, and you find out the answers for each one and see if it's correct. Right? So that's your challenge to complete that. By using, please refer to the notes, go through it again before you attempt the activity. It's going to help you. Now, let's look at expanded notation. I told you earlier, I'm going to explain expanded notation, and that's breaking down a number into its specific values. Now, your number here is 47639, which is read as 47,639. So, the 9 is the units, 3 is tens, 6 is hundreds, 7 is thousand, and 4 is 10,000. So, if I'm breaking it down, I'm going to say 4 times 10,000, 7 times 1,000, 6 times 100, 3 times 10, and 9 times 1. So 4 times 10,000 gives me 40,000. 7 times 1,000 is 7,000. 6 times 100 is 600. 3 times 10 is 30, and 9 times 1 is 9. So altogether, my answer will add up to 47,639. Now, you've got an activity. You must break down these numbers. All are up to 10,000. So I've got 36,425. Done for you, and you do the others similar to the one I've done. So 3 times 10,000, your first digit, then 6 times 1,000, 4 times 100, 2 times 10, and 5 times 1. Again, 3 times 10,000, which is our first one, then 6 times 1,000, the next one, 4 times 100, 2 times 10, and 5 times 1. And you'll end up with 36,425. So you will complete this activity on expanded notation, but we've done it right through as we are going along, so you should know what expanded notation is. Now, comparing and ordering of numbers. We did speak about this, where you will compare numbers to see which one is bigger than the other, and you'll be able to put it in order of ascending or descending order. That's what we're starting off with first. Now, children generally get confused with ascending and descending order. So if we don't explain to them smallest to biggest or biggest to smallest, it is a problem. So they can do it the incorrect way. Now, always remember ascending, going up, So your numbers start from smallest to biggest. Descending, D for down, so it's coming from biggest to smallest. So ascending order, remember again, smallest to biggest. I've given you an activity which could confuse you a bit, but I will explain to you as we're going along. Now, there's the numbers all jumbled up here in different order. 4,162, 2,614, 4,612, 6,412, 2,164. Now, you've got to put this from smallest to biggest. Now, generally, when you're doing smallest to biggest, you look at the first digit of a number. And you'll find the smallest number, and then you'll choose this one that starts with the smallest number, and that will be your first number. But what happens if you've got two numbers that start with the same digit? What are you going to do then? So for example, here I've got the smallest digit starts with 2 here. I've got 2, 6, and I've got 2, 1. Now my smaller one is not 2, 6, it's 2, 1. So I will start with 2, 1, and there I wrote here 2, 1, 6, 4, and then 2, 6, 1, 4. Then I've got 2 sets of 4s as well. So let's look at the next digit. I've got 4, 1, and 4, 6. I will start with 4, 1, 6, 2, and then 4, 6, 1, 2. And finally, there's 6, no other number. So 6, 4, 1, 2. So that's how I'll identify, and I'll be able to put it in order. So let's go back. 2, 1, 2, 6. So 2, 1, 6, 4, 2, 6, 1, 4. 4, 1, 4, 6. I'll start with the 4, 1, it's smaller. So 4, 1, 6, 2, 4, 6, 1, 2, and 6, 4, 1, 2. That's how we will put it in ascending order, and it is from smallest to biggest. When doing ascending order, you look for the smallest number, as I said, to start with, and you'll end up with the biggest number. Now, descending order is the opposite. We'll start with the biggest number, and we'll end up with the smallest number. Let's go again. Here again, the biggest number starts with 6. No other number starts with 6, so I can put that down immediately. 6,412. Now, the next biggest number starts with 4. 4, 1, 4, 6. Now I have to take the bigger one now because it's descending order. So I'll start with 4, 6, 1, 2. Then I'll go to 4, 1, 6, 2 because 4, 6 is bigger than 4, 1. Then I've got 2 sets of 2s. 2, 6, and 2, 1. Now obviously I'll take the bigger one, which is 2, 6. 2, 6, 1, 4, and then 2, 1, 6, 4. So I've started with my biggest number, and I've ended up with my smallest number. That's descending order. So please follow those rules that I explained to you if you're getting confused. And if there's more than 2 numbers that have the same digit, look at if the first 2 digits are the same, look at the third digit. That's going to help you, and you continue doing so as you're going along. Then there's an activity here for you, which is greater than and less than. You're going to look at the numbers and you're going to compare it, ascending and descending order. Remember the rules I told you. If the first digit is the same, look at the second. If the second digit is the same, look at the third, and so on. Then you'll be able to put it in highest to lowest form. So please complete these activities, and I hope you enjoyed this lesson. The next lesson we'll be doing is rounding off. So that's very important because there's lots of rules to learn there.